Section 5.3 is about the logarithmic function and its applications. So we're going to start by taking a look at the graph, identifying the domain, the range, the concavity, etc. And then we're going to look at some real-world applications for the log function. So we'll start by considering the functions f of x is equal to natural log of x, and g of x is equal to the common log of x. And we're going to complete this table below, so you'll need your calculator for this. And so we'll start with like ln of 0.0001 gives me negative 9.2. So you're going to go ahead and pause the video, fill this out here, and then we'll come back and take a look at kind of what we see going on. Okay, so these are the values I got when I went through and for each of those x's found either the natural log or the common log. And what I see here is they both started negative, and eventually they hit 0, and that happens when x is 1. And then they start becoming positive. And here I see them growing really, really slowly, whereas when we were looking at x is 0.0001, we saw it growing much more quickly. So here it was jumping by ones the whole time. Here it was jumping by about 2 to 3 until we get to where it's positive, and then we start to have the growth slow down. Okay, so that's kind of the pattern I'm seeing. Let's look at letter B. It says if you plug in x equals 0 or negative numbers for x, what happens? So let's give that a try. So how about ln of 0? All right, so error domain, that means x equals 0 is not in the domain. And let's try a negative number here, so negative 5. So again, well, now we're getting a non-real answer, but again, still not in the domain of our functions here, of our logarithms here. So if I try 0 or a negative number, the functions f of x and g of x are not defined. All right, so based on that and what we saw here, what is the domain of f of x and g of x? Okay, so what we learned from part B is that x can't be 0 and it cannot be negative. So x definitely needs to be positive. And if we look at some of these positive values we've tried here, these all definitely seem to work. So for part C, our hypothesis is, and this is actually true, is that our domain is x is greater than 0. All right, so part D, you're going to sketch the natural log. And you've already made this table here, so that'll work out really well to be able to sketch on. And then go ahead and see if you can find any vertical or horizontal asymptotes. So pause the video, give that a try, and then we'll come back and see if we've gotten to about the same place. Okay, so here's what I got for the graph of the natural log. So I have kind of cozies up right here against that y-axis. It comes up to the point 0.1, and then it just keeps continuing and growing, okay? So any vertical asymptotes, so vertical asymptotes would be this way. And basically what we're looking for is if we have a vertical asymptote there, then the function is going to come and sit right next to it as it goes to negative infinity or up to positive infinity. Okay, and that can do that from either side. So the function could be coming over here, zigzaggy or something, and hits that asymptote and then takes off to the moon or infinity and beyond. Okay, so that would be our vertical asymptote. And it does appear that we have one here, right here at x equals 0. Looks like this natural log function is going to cozy up to that line but not cross it. So for vertical asymptotes, we have x is equal to 0. And then horizontal asymptotes are the ones that go this way, and that's with your y value. And with a log function, okay, this looks like it might be maybe sort of leveling off, but it's not. It just continues growing ever so slowly, ever so slowly. And so it is eventually going to go to infinity. So for horizontal asymptotes, we have none.